Welcome back. This is Mrs. Rubright with Algebra 1 Honors, and today's lesson is 4.2, using intercepts. Alright, so the equation in two variables, x and y, that can be written in the form of ax plus by equals c. So this is going to be a number x plus a number y equals just a number, a constant, right? That is your standard form of an equation. For real numbers, a, b, and c is a linear equation in two variables, okay? So that is your standard linear equation. The form ax plus by equals c, where a and b are both 0, is called the standard form of the linear equation, where they're not both 0, right? The solution of an equation in two variables, x and y, is an ordered pair, any ordered pair x, y, that makes the equation true. All right, so your solutions are the ordered pairs that make it true. So, define a linear equation in two variables. Complete the table of values to find solutions of the linear equation x plus y equals 5. So this is our equation. Okay, it's in standard form. So we're going to plug in these x values to get our y values. So the easiest thing to do, in standard form, you can quickly get your intercepts, right? So like if I cover up my x, if x is 0, then y is 5. So my y-intercept is 5. When x is 0, y is 5. Right? And then my y-intercept, I'm sorry, that is my y-intercept. My x-intercept, when y is 0, x is 5, right? If you just cover up the y, then x is 5. So x is 5, y is 0. So those are your two intercepts, right? Other than that, it's really only going to be easy to solve this quickly if you put it into y equals mx plus b. Solve for y because we're going to plug in these x values to get our y. Okay? So I'm just going to subtract x from both sides, and I get y equals negative x plus 5. Now that it's written in y equals mx plus b, I can tell that my slope is negative 1, and my y-intercept is 5, right? So I could graph it just based on that, but we're going to do some ordered pairs and graph it this way instead, just to show how to do this. So if I plug in a negative 2, negative 2 is 2, 2 plus 5 is 7. If I plug in a negative 1, negative 1 is 1, 1 plus 5 is 6. If I plug in a 1, negative 1 plus 5 is 4. If I plug in a 2, negative 2 plus 5 is 3. If I plug in a 3, negative 3 plus 5 is 2. If I plug in a 4, negative 4 plus 5 is 1. If I plug in a 6, negative 6 plus 5 is negative 1. Negative 7 plus 5 is negative 2. So you see this nice pattern, 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2. We see that it's creating this pattern. So these are our ordered pairs, negative 2, 7, negative 1, 6, 0, 5, 1, 4, 2, 3, 3, 2, 4, 1, 5, 0, 6, negative 1, and 7, negative 2. And we can plot these ordered pairs. So negative 2, 7, negative 1, 6, 0, 5, 1, 4, 2, 3, 3, 2, 4, 1, 5, 0, 6, negative 1, 7, negative 2. All right? You guys see those coordinates all being graphed? What appears to be true about the points that are the solutions of the linear equation? They all lie on a straight line. What is the minimum number of points you would need to plot, to graph a linear equation? How many points do you need to form a line? What's the minimum number of points to form a line? 2. Any 2 points determine a unique line. You should graph a third point as a check on the first 2 points, right? If the third point's not on there, then you know you messed something up. So the third point will just verify that you didn't make any mistakes, okay? the third point should be on the same line as the first two, right? If it's not, you messed up. To determine whether an ordered pair x1, y1 is a solution of the linear equation, substitute the values of x sub 1 and y sub 1 into the linear equation. If two sides of the equation are equal, then the ordered pair is a solution. Which ordered pair is a solution to this equation? So we have an equation in standard form, and we want to know, does 0, 3 solve? Is that on a point on that line? Is it a solution for the line? Does it fall on the line? Let's see. 3 times 0. Right, because we're plugging in a 0 for x and a 3 for y. So 3 times 0 is 0. 5 times 3 is 15. 0 plus 15 equals 15. Does 15 equal 15? Yes, so yes, it is a solution. Let's try the other one, 8, 1. So 3 times 8 plus 5 times 1 equals 15. 24 plus 5 equals 15. 29 equals 15. True or false? False. So it is not a solution. Make sense? What do you know about the point 0, 3 and its relationship to the graph of 3x, so the same equation? What do we know? That that point falls on that line. That the point 0, 3 falls on the line 3x plus 5y equals 15. Explain how you know that 3x plus 5y equals 15 is a linear equation. Alright, so it is written in the form ax plus by equals c, where a, b, and c are real numbers. So if it's written in standard form, then we know it's linear because standard form is the standard form of a linear equation, right? So if it's written in that form, then yes, it's going to be linear. If we threw this into y equals mx plus b, we would kind of have a better idea of what it looks like just without even thinking, right? The graph of the linear equation is a line. To graph the line, it is necessary to plot only 2 points. However, it's a good idea to plot a third point as a check. For linear equations written in standard form, 2 good points to plot on a line crosses the axes, right? Your x-coordinate of the point where the line crosses the x-axis is called the x-intercept and is found by substituting a 0 in for y in the equation of the line. The y-coordinate of the point where it crosses the y-axis is called the y-intercept and is found by substituting a 0 in for x on the equation of the line. All right, so remember how I told you guys the cover-up method to get the x and y-intercept? So your x-intercept is when y is 0, cover it up. Divide by 2 on both sides, x equals 2. Right, so when y is 0, x is 2. When x is 0, your y-intercept is at 4. And then we're just plugging in a third point just as a good check, just for good measure. So if we plug in a 1 for x, we'd have 2 plus y equals 4. Right? Subtract 2 from both sides, y equals 2. Write the value for y next to the 0 in the first row of the table. All right, so we have our table points. Next, substitute a 0 for y. Okay, we already did this, right? So x equals 2. Okay, so then it says choose another value for x to solve for y. So they're plugging in a 1. Okay, so when they did that, they had 2 plus y, so they got y equals 2. Plot the points. All right, so we have 0. Okay, so our y-intercept's 4, our x-intercept's 2. right? Y-intercept 4, X-intercept 2. That's 0. Sorry, I made a little error right there. That should have said a 4, right? We did it right here. We just did it wrong in the work. That should be a 4. Okay, so we have a y-intercept of 4 and x-intercept of 2. Y-intercept of 4, x-intercept of 2, and then our extra point, just for good measure, was 1, 2. 1, 2. And that is the equation of our line. List 3 other solutions. Okay, so look, we're going down 2 over 1. Down 2 over 1, we could say 3, negative 2. We could go up 2 over 1, right? We could say negative 1, 6. Up 2 over 1. That would be, am I counting right? Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, yeah. Negative 2, 8. Right? Those are all on the line. I'm just following my slope. Why should you find the x and y intercepts when making a table of values to graph the linear equation? Because it's the only thing that's really easy to do when it's in standard form. Your x and y intercepts, so you just use the cover-up method. It's really the only thing the standard form is really useful for. So the calculations are simple. The x-intercept and y-intercept indicate where the graph crosses each axis. It's easy to find, right? The cover-up method. Suppose that in part E, the 3 points do not lie on a straight line. What would this tell you, and what should you do? So if the 3 points didn't end up on the same line, then it means that I messed something up somewhere. It means you made a calculation error somewhere. Go back and recalculate the points. Right? It means you messed up. You made a silly mistake somewhere. Vertical and horizontal lines. So if we were going to graph x equals 3, where does x equal 3? X equals 3 on this point and everywhere along this vertical line. Because think about it. This point is 3, 0, 3, 1, 3, 6, 3, a million, 3, negative a million, 3, negative 200, 3, negative 2. The only point that's in common is that every single x value on this vertical line is 3. So this is the line x equals 3. The line y equals negative 4, go to negative 4, y is negative 4 here, and everywhere on this horizontal line. Because no matter what the point is, every single y value on this line has the same y value of 4. So we have 0, 4, 0, negative 4, 2, negative 4, right? This is y equals negative 4. We have 8, negative 4. We have 100, negative 4. Negative 100, negative 4, right? Everything on this horizontal line has a y value of negative 4. Describe the graph of the line y equals 1. It's a horizontal line where all the points have a y value of 1. Describe the graph of x equals negative 2. X equals negative 2 is a vertical line where all the x values on the line are negative 2, right? The x portion of the points is -2 on every single point on that line. A linear equation in the form of ax plus by equals c, where c equals 0, has a special property. To see what the property is, look below at the table and graph the equation. -4x plus 3y equals 0. So you're going to get, if I plug in a 0 for x, my y is 0. If I plug in a 0 for y, my x is 0. So your x and y-intercept are both the origin. They're the same. So it's a linear equation, a line that goes through the origin. Which is 0, 0. So they both, like the x and y-intercepts are both at 0, the origin. Okay, make sense? Lines through the origin. So if it's going through the origin, we know that we have 0, 0. Well, let's just plug in some other numbers. So personally, I would turn this into y equals mx plus b, but that's just me. If not, I mean, I guess we could just plug in. So 2 times 1 minus 3y equals 0. 2 minus 3y equals 0. Subtract 2 from both sides. -3y equals -2. Divide by -3. Y equals 2/3. But I plug in a 2. 2 times 2 minus 3y equals 0. 4 minus 3y equals 0. Subtract 4. -3y equals -4. Divide by -3. Y equals 4/3. So we have 0, 0. We have 1, 2/3. And we have 2, 4/3, which is 1 and 1/3. 1 and 1/3. Okay. And we need to connect this out. And that is the equation of our line. Would it have been easier to use x values of 3 and -3 to graph the line? Why or why not? So if I use 3 and -3, I'd have 2 times 3 minus 3y equals 0. 6 minus 3y equals 0. -3y equals -6. I get y equals 2. Isn't a whole number easier to graph? Yes, it'd be easier because you get whole numbers. So you would have gotten like 3, 2, right? And -3, -2 is the answers that you would have gotten for that, and that would be easier to graph. If c does not equal 0, can the graph pass through the origin? Why or why not? No. Right? No. If c does not equal 0, then a of 0 plus b of 0 equals c is not a true statement. So the point 0, 0 is not on the graph. Okay? If it's not equal to 0, then that's not going to go through the origin. Alright, so here is some practice. So, tell whether the ordered pair is a solution to the equation. So I want you guys to try out number 1 real quick. Tell me whether or not, is that a solution? Yes or no? Raise your hand if you think it's yes. Raise your hand if you think it's no. All right, you guys are right. It is not a solution. -4 does not equal 4. Try number 2. Is it a solution? Yes, it is. Good job. All right, and then I want you guys to try and graph number 3. Try and graph number 3. All right, did you guys get 0, 3, -1.5, 0, or -3/2, 0? And then I plugged in 3 for my extra point, which kind of got a little off the graph, but it's okay, 3, 9. Try number 4. You can plug in any y values you want there. It's just going to be a vertical line. So your x equals -2. It's a vertical line. So your y values can be any number you want to put there. And our third one. When x is 0, y is 0. When y is 0, x is 0. When x is -5. And then when y is -4. And that is your last practice problem. I hope you guys enjoyed the lesson on 4.2, using your intercepts. Please like and subscribe, and have a great day.